Good evening everyone. So today we will be starting redox reactions. So tell me, what do we mean by redox reactions here? So those reactions in which simultaneous oxidation and reduction is taking place. See here, here redox, it means reduction and oxidation. Both are taking simultaneously. So those reactions are considered as redox reactions. Okay. So now what exactly mean by reduction and what is mean by oxidation? We need to know these things first before going to study these redox reactions right now. So here reduction means we have different definitions for oxidation and reduction. So in terms of oxygen, see when I say oxidation, addition of oxygen is called oxidation. For example, I have element A. To this element A, I am adding oxygen so that it is becoming AO2, something like this. So what we did here, to the element A we added oxygen. So now element A is undergoing oxidation, I can say. Addition of oxygen is what? Oxidation. Here you can look here, magnesium, to this oxygen is added, it is becoming magnesium oxide. So what is this process? Oxidation. Okay. Now similarly when it comes to reduction, it is something like opposite of oxidation. Okay. So now reduction means I can say removal of oxygen is called reduction. For example, I am converting AO2 to A. So what happening here? From AO2, it means we removed these two oxygens, so it is becoming A. It means what I can say, removal of oxygen is called reduction. Okay. So from copper oxide, I am removing oxygen using a carbon here. See, copper oxide converting into copper. It means what happened to copper here? Copper oxide is converted into copper. It means oxygen is removed. Removal of oxygen is reduction. So copper oxide is undergoing what? Reduction. Whereas carbon is undergoing oxidation, from carbon atom to carbon oxide. Carbon monoxide it is converted. So it means what is this process? Oxidation. You got what do we mean by oxidation and reduction in terms of oxygen? Right. So loss of oxygen is called reduction, gain of oxygen is called oxidation. That's it. Next, look at here, removal of hydrogen. For example, here H2S we have. From this sulfur H2S sulfide, I have removed these two oxygen, hydrogen, so that it become sulfur atom. So removal of hydrogen atoms is called oxidation. What I am saying, removal of hydrogen atoms is called oxidation. Whereas addition of hydrogen atoms is called reduction. To the sulfur we are adding two hydrogen atoms. So this process is called reduction. So addition of hydrogen atoms are called reduction, whereas removal of hydrogen atoms oxidation. Okay, right. Next, increase in positive charge. See, this increase in positive charge, decrease in positive charge, increase in positive charge, decrease in positive charge raises here due to electron loss and electron gain. For example, here iron plus 2 is converting into iron plus 3. So what happening here? Plus 2 is converted into plus 3. It means, for example, look at here. When I have element A, from this if I remove any electrons. So for example, I am removing 2 electrons from element A. See what we are removing? Electrons. What is the charge on electrons? Negative. So how many we are removing? 2 electrons I am removing. So that it will become A plus 2. When we remove electron, atom converts into its respective cation. How many electrons are we removing? From neutral atom we are removing 2 electrons, so it becomes plus 2. Okay. If I add 2 electrons to this, if I add 2 electrons to this atom A, 2 electrons I am adding. So what it becomes? A minus 2. Okay. So now during this change, see, is there any charge on element here? Atomic form, no charge. So it is 0. When the charge is increasing towards positive, it means 0, 2, plus 1, plus 2, plus 3 like this. If that is the thing you are observing here, it means that process is called oxidation. Whereas charge is converting from 0 to negatives like -1, -2 like this. That is called reduction. So simple, removal of electrons is considered as oxidation. Addition of electrons, reduction. Okay, so look at here, removal of electron. What happens by removal of electrons? Oxidation. See, charge +2 is converting into +4. If charge is increased, then we can say it is oxidation. Okay, if charge is decreased, reduction. See here, +3 is converting into +2. It means reduction. Reduction is happened due to addition of electrons. Okay, is that clear? Okay, so we have studied in 3 ways. First one is with respect to oxygen. Addition of oxygen is oxidation. Removal of oxygen is reduction. Addition of hydrogen is reduction. Removal of hydrogen, oxidation. Next, addition of electrons, reduction. Removal of electrons, oxidation. These are the 3 ways you can define oxidation and reduction. Okay, during a chemical reaction, if both oxidation and reduction processes are involved, then we can consider those reactions as redox reactions. So what are redox reactions? Both oxidation, reduction taking place simultaneously in a given reaction, then that reactions are considered as redox reaction. For example, look at here, I have zinc plus copper +2 converting into Zn +2 plus Cu0. So it means what happening here? From zinc, 0 charge converting into +2. So what does this mean? Charge is increased. It means, see here what we discussed, oxidation, right? See, loss of electrons. See, increase in charge, increase in oxidation number, increase in positive charge is what? Oxidation. From 0 to +2 means this is oxidation. Now how many electrons lost during this process? 2 electrons. 0 converting into +2 means 2 electrons is lost here. Okay, so now copper +2 is converting into 0. So it means what is this? Reduction. Why? Number is reduced. See, +2 is decreased to, so reduction in number now, so that is considered as reduction. So this can be reduction. So by how many electrons it is gained so that it becomes 0? By gaining 2 electrons. So here by losing 2 electrons undergoing oxidation, by gaining 2 electrons undergoing reduction. It means during a redox reaction, number of electron lost in oxidation will be equals to number of electron gained in reduction. This must be satisfied. This condition must be satisfied during redox reaction. If here 2 electrons are lost, in reduction the 2 electrons must be gained. Same number of lost and same number of gained should be satisfied. Is this clear or not? Right. Now here I am representing some charges here. Here I have written 0, +2, +2, 0 like this. Those charges are called their oxidation numbers. What we should call? So how can we identify these oxidation numbers for given elements or given compounds? There are certain rules that to be followed while giving these oxidation numbers. Okay, so we'll see those rules. So first of all, what is mean by oxidation number? Here it is an imaginary charge developed over the atom of an element when it goes from its elemental free state to combined state in a molecule. For example, here you have seen magnesium. See, magnesium is in free state now. Okay, now when it is undergoing combined, like undergoing reaction with oxygen, so what it is forming? Magnesium oxide is formed. Magnesium oxide is formed. So now once again read, it is an imaginary charge developed over the atom of an element when it goes from its elemental free state to combined state. See, elemental free state to combined state in a molecule. So now what is the charge here? Whenever an element is given in its free state means its atomic form or its molecular form, whatever the way it exists in nature or when we extract it from some source. Okay, so now we know, 2 minutes it will be on. Yeah. So definition is clear now. So what is definition again? It is an imaginary charge present in an element, in a compound, an element when it is in the combined form or in its free state. For example, I have just now I told you, now element, for example element A I have, upon treating with oxygen converting into AO2 form. So here element here 0 converting into here some charge, okay, because it is forming some compound here, okay. So now whenever we have an element in its free state, we can say the oxidation state of that element in its free state will be 0. How much? 0. Now in its compounds, how can we calculate its oxidation state? There are some rules to be followed in order to calculate oxidation state of an element in its compounds, okay. We will look into those rules now, okay, right. So now when we are calculating oxidation state, we need to follow this statement. Look at this statement. The calculation of oxidation state is based on the assumption a complete transfer of electron takes place from a less electronegative atom to more electronegative atom. For example, I have something like HCl I have. In this, which is more electronegative? Chlorine, right now. So the bonded electrons in HCl, the bond pair electrons are taken towards more electronegative atom, that is chlorine. If it is taken towards chlorine, now total 2 electrons in this bond are taken by chlorine. It means chlorine will get negative charge, hydrogen will get positive charge. Like this, whenever we are calculating oxidation state of elements or atoms in a compound, you should follow its electronegativity values, okay. More electronegative atom will take the bond pair electrons from the less electronegative atom. Therefore, less electronegative atom will get positive charge, more electronegative atom will get a negative charge. So now what is the oxidation state of hydrogen in HCl? What is the charge we got here? +1. So +1 will be the oxidation state of hydrogen in HCl, whereas for chlorine -1 will be the oxidation state of chlorine in HCl. Like this we need to calculate, okay. So now we have few more things here. Look at this, the important rules to determine oxidation state of an element. First rule is the oxidation number of an element in its elemental form. What I told you, for example here we know oxygen element, like oxygen will be in not in like atomic form, but it is in molecular form, O2 form right now, okay. So now oxidation state of like oxygen in O2 will be 0. Why it will be 0? Both the elements are having same electronegativity now, therefore the bonded pair electrons will be taken equally. So there is no polarization, there is no electronegativity difference. Therefore oxygen's oxidation state in its molecular state will be 0. So any compound like any element in its pure state will be how much? 0. For example, hydrogen will also be in H2 diatomic form. What is the oxidation state here also? 0. Halogens are also like F2, Cl2, like X2 form. In all those compounds oxidation state will be 0. So for example ozone, oxygen will also be in ozone, O3 form. What is the oxidation state here also? 0. When an element is combined with itself, then oxidation state will be 0, like this, okay. So now for example we know calcium, like it will be in Ca, like this, atomic form. So what is the oxidation state here? What is the charge you are seeing in this? So there is no charge on it. So whatever the stable state for a particular element in its atomic form, the charge will be 0. So oxidation state will be 0, okay. So when this calcium is converting into Ca to Ca+2 by losing 2 electrons, because it is second group element now, so valence electrons are 2. So by losing 2 electrons it becomes Ca+2. So it means here oxidation state is 0, by losing 2 electrons it is becoming +2. So when an element is existing in its ionic form, what I am saying? When an element existing in ionic form, whatever the charge present on that ion will be its oxidation state. So what is the oxidation state of calcium here? +2. In its elemental form 0, like this. For sodium also, Sodium here, how much its charge you are seeing here? It is a pure atomic form of sodium. So here it is 0. But whenever sodium react with some species, what happens? All alkali metals always have +1 oxidation state. What I am saying? Whether whatever the species it may be combining, always alkali metals will be having +1 oxidation state, because alkali metals are highly reactive due to presence of that extra 1 electron after noble gas configuration. After neon gas configuration, sodium will be having one more extra, that 11th electron right now. So by losing that 11th electron, it becomes it becomes Na plus and 1 electron is released out. So how many electrons are there here? Neon gas configuration, 10 electrons are there. So that's why it is getting noble gas configuration. So all the alkali metals will exist in which oxidation state? +1 oxidation state. Remember this. Okay, in any compound, oxidation state of alkali metals will be +1. Okay, right. Next, oxidation number of any element in simple monoatomic ion form will be equals to charge present on it. For sodium in Na plus form, what is oxidation state? +1. Okay, next, oxidation number of fluorine in its compounds with other elements always -1. Why? Because fluorine is the highest electronegative element in the periodic table. So therefore, whenever fluorine combines with any other element, what happens? Fluorine always will be with a negative charge because it is more electronegative. So fluorine, when it combines with itself, will be having F2 form. So here we will be seeing 0 oxidation state. Okay. Now in any other case, whenever fluorine react with any other element, oxidation state of fluorine will be -1. How much? -1. It never shows +1 because it is the most electronegative element in the periodic table. So these are standard rules to be followed because these are conceptual only, right? Okay. For example, here, what is the highest electronegative element in the periodic table? First one is fluorine. After that, oxygen. Okay. So now, whenever we have oxygen combined with itself, its oxidation state will be 0. Now, oxygen combined with any other element, oxygen will be having negative oxidation states. But when it is combined with fluorine, positive. Why positive? Because fluorine is more electronegative. For example, fluorine and oxygen together forms few compounds. For example, here I have OF2 type of compounds and O2F2 type of compounds. This oxygen and fluorine combine to form. So now look at here, OF2. It means I can write it like this. Okay, which is more electronegative, oxygen or fluorine? Fluorine. Here I already given electronegativity order of fluorine is more. So the bonded electrons are taken towards fluorine. The bonded electrons are taken towards fluorine. It means with respect to this bond, oxygen should get +1, fluorine should get -1. And here also fluorine will take, so with respect to this bond, oxygen fluorine will get -1 +1. So overall charge of oxygen is how much? So +2 is the oxidation state of oxygen in OF2. Similarly, you tell me for O2F2. See, OF we have like this. Okay, so here -1, here it should be +1, and here -1, and here it should be +1. So oxygen here are, what is the oxidation state in O2F2? It is +1. +1 for one oxygen atom. Here it is for one oxygen atom +2. Here for one oxygen atom +1. Is this clear or not? So for two oxygen, each one +1 and +1 like that. Okay, right. So now simply we'll make one formula for calculating this oxidation state. Wait for some time. Okay. So the next, when oxygen combined with any other element, what I told you, when oxygen combined with any other element, oxygen will always be having minus oxidation state except with fluorine. Okay. So now look at here, oxygen combined with sodium. We know alkali metals are always having +1 oxidation state. Now I want to find for oxygen. You consider it as X. Now how many alkali metals are there? 2 are there. Each one will be having +1 charge. Overall molecule, do you have any charge on it? No. Overall molecule is neutral now, so equalize it to 0. So what is the value of X here? We will be getting So plus 2 comes this side, minus 2. So minus 2 is the oxidation state of oxygen in Na2O. Okay. Similarly, if I write H2O, water, tell me here what happens. How many hydrogen atoms are there? 2 are there. Each hydrogen atom, which is more electronegative out of these two? Oxygen. So definitely oxygen minus hydrogen plus. So each oxygen hydrogen is monovalent, so plus 1 will be the charge. Okay, plus X. Overall molecule is neutral, so 0. So X will be minus 2. So minus 2 is the oxidation state of this oxygen atom. Is this clear or not? Right. One more thing here, I am writing hydrogen peroxide. Hydrogen peroxide means H2O2. Now tell me here, how many oxygen atoms are there? 2 are there right now. So I want oxidation state of one oxygen atom. Okay, so I can take it as 2x plus 2 hydrogen atoms are there, each one will be having plus 1 and overall molecule is neutral, so equals to 0. So 2x will be minus 2 and x will be the charge of one oxygen atom, minus 1. So in peroxide, what is the oxidation state of oxygen? Minus 1. So whenever you have minus 2 oxygen state for oxygen, so what I told you, so in Na2O, so in Na2O, oxidation state of oxygen is minus 2. So whenever oxygen is having minus 2, so you should call it as oxide. What is that? Oxide. So in H2O2, you have seen it as oxygen with minus 1. See, 2 oxygen atoms minus 2, but 1 oxygen atom it will be minus 1. So in this case you should call it as peroxide. What you should call? Peroxide. Okay. So whenever you got oxygen state of oxygen as minus 1, you should call it as peroxide. And here I have KO2 I am writing. So KO2 means 2 oxygen atoms are there. So 2x I can write plus how many potassium atoms are there here? 1. Potassium is alkali metal now, so plus 1. Overall it is neutral. So x will be minus 1 by 2. So whenever you got minus 1 by 2 as the oxidation state of one oxygen atom here. See, for 2 it will be minus 1. For 1 it will be minus 1 by 2. So for oxidation state of minus 1 by 2, like minus half you got for one oxygen atom here. That should be called as superoxide. What is that? So you have 3 types of oxides: oxides, peroxides, superoxides. Different oxidation state, different names. You should remember this. Okay. Next thing is, and when you will be having positive oxidation state for oxygen, only when it combines with the fluorine. Okay, next. Look at here, oxidation state of alkali metals always will be +1, whereas alkaline earth metals it will be +2, like magnesium, calcium will be having +2 in their combined states. Okay, next, oxidation state of halogens generally -1 when they are bonded to less electronegative element. For example, here we have seen OF2 case. So which is electronegative? Fluorine is electronegative. So fluorine will get -1 charge, 2 fluorines are there, so that oxygen will get +2 charge. Now I am writing OCl2. Now tell me here, which is more electronegative, chlorine or oxygen? Oxygen is more electronegative than chlorine. Just now I told you second most electronegative element is oxygen. Okay, therefore in these it will become chlorine positive, oxygen negative, because bonded electrons are taken towards oxygen. So -1 +1. So this side also -1 +1. Okay, so what is the oxidation state of oxygen here? -2. Okay, whereas chlorine +1, like this, depending upon with what and which element halogens are attached or combined decides their oxidation states, purely based on electronegativity values. Okay, now oxidation state of hydrogen generally seems to be how much? +1. But when these hydrogen attached with the metals, mean combined with the metals, for example, hydrogen can combine with sodium and forms sodium hydride, and with combined with calcium and forms calcium hydride. So in this case we know alkali metals always how much? We have a fixed value of +1. Alkali metals are with +1, so that hydrogen will be -1. So here calcium, alkaline earth metals, how much I told you? +2. It means this each hydrogen will be, two are there, each one will be the -1. So 2 hydrogens are there, -2. Overall molecule is neutral, like that. Okay, next look at here. When we are calculating in molecules, the algebraic sum of oxidation numbers of all atoms in a neutral compound is 0. For example, here I am taking KMnO4 I am taking. KMnO4 I am taking. Okay, so now this it looks like neutral molecule now. So total overall charges of all this element should be equals to 0, because it is a neutral molecule. Now for alkali metal, what is the charge? +1. Okay, how many are there? Only 1. Plus I want to calculate for manganese here, so consider it as X. Plus how many oxygen atoms are there? 4 are there. So here like oxygen will be in oxide form, so its oxidation state will be -2 in oxides. Okay, therefore your X value will be how much? See, 4 2s are 8, -8 +1, -7. If I send that side, it becomes +7. So +7 is the oxidation state of this manganese in KMnO4. So is it clear or not how to find oxidation state? Now tell me for sulfur in sulfuric acid, for this sulfur, fast. +6. How can we calculate? So consider its value as X, and how many hydrogens are there? 2, each one +1, and how many oxygens are there? 4, each oxygen -2, overall neutral, so 0. So X will be -2 + 6. See, 4 2s are 8, -8 + 2, -6. So I can say X will be +6, like this. Very simple now, right? Next we will move forward. So look at here, try to calculate in this case. Cl2O we have calculated already. Now tell me here, what is the oxidation state of chlorine? In this case ClF3 +3. Simple, because chlorine is less electronegative than fluorine. How many fluorines are there? 3, each one -1, overall 0, because neutral. So it will be +3 for chlorine. And here you tell me for iodine. periodic acid. What is the name of that compound? Periodic acid. So how can you calculate? Huh? No, here it's oxidation. That's why find its oxidation state. Plus 7. So X will be for iodine. One hydrogen atom is there. 1 into plus 1 plus 4 oxygens, 4 into minus 2, overall neutral, so 0, minus 8 plus 1 minus 7. So X will be plus 7. So plus 7 is the maximum oxidation state of halogens. What I am saying? Maximum oxidation state of halogen. So whenever you have maximum oxidation state in like these compounds, you can call them as per. Like perchloric acid. If I say HClO4, what you should call? Perchloric acid.
Only for halogen or other compounds?
Yeah, especially for halogens here I am saying. Okay. Next, here we have HClO4. What is the oxidation state there also? Tell me. Same. Plus 7 you will get for chlorine. As it is. Like HClO4, HiO4, HClO4. Next. So tell me here, oxidation state of sulfur in sulfate. Simple, just now you have did that. Plus 6. See, simple, you have sulfuric acid, I have given previously. Now here we have sulfate ion. So now sulfuric acid is neutral, so we equalize it to 0. But here it is ionic form, so you should equalize it to that whatever the charge present on that ion. Okay, so here sulfur X I am taking plus how many oxygens? 4. Each oxygen will be an oxide, it means minus 2. So it will be X will be minus 2 plus 8. So it will be plus 6. That's it. Simple. Okay, even if you do like from here also you will get plus 6 because we know hydrogen here is less electronegative than these two elements, therefore it will be in plus 1 form. How many are there? 2 hydrogens. If these 2 hydrogens are removed as place, the remaining charge on this part will be minus 2. That's why sulfate, sulfuric acid both will be having plus 6 oxidation state for the sulfur, which is central atom here. Okay, right. Let's move forward. Here you tell me, and before doing this, before doing this, just tell me for few basic basic compounds first. CO2, CO3, 2 minus. I just want for this carbon in all these cases, K2, Cr, 2O7, CrO4 minus 2. Fast, for chromium here in this case. Tell me everyone, fast. CO2 plus 4 because each oxygen is minus 2, 2 are there, minus 4 it will be. So it should be, carbon should be plus 4. And here, very simple, X plus 3 oxygens, each one will be minus 2. Overall charge is minus 2. So minus 2 plus 6. 4. Okay, like this. And one more thing. What is the maximum oxidation state of a particular element? How can we get that value? For example, what is the maximum oxidation state shown by carbon? If I ask, what is your answer? 4, plus 4. How you are saying plus 4? Number of valence electrons you count. What is the atomic number? 6. How many valence electrons are there? Like 2s2, 2p, 2 you are saying. These are the valence electrons. So maximum this many electrons can participate in chemical reactions. So if we remove all those 4 electrons which participated in chemical reactions, so it can show plus 4. Similarly, you tell me for nitrogen.
Plus 6.
How many are there valence electrons? Just look at its electronic configuration. That's it. Nitrogen atomic number is 7. So you can write 1s2, 2s2, 2p, 4 over 2p, 3. It means this highest n value is there now. 2s2 and 2p3 will be its valency electrons. So it can form 5, like only like maximum of 5 electrons can participate in chemical reactions. So losing all these 5 electrons, it can show maximum of plus 5. Okay, now if I ask what will be the minimum oxidation state of nitrogen, what will be the minimum oxidation state? See how many valence electrons are there? 5 are there. Still how many we can fill in that valency? 3 more we can fill, so that overall becomes 8. Maximum 8 we can have for like s orbital is 1 orbital we have, s orbital is 1. How many p's are there? P orbitals are there, 3 p orbitals. So maximum electrons how many we can fill? 6 here, 2 here, total 8. Already 5 are there, remaining how many we can fill? 3. So minimum oxidation state of nitrogen is -3 to maximum oxidation state is +5. So for nitrogen, all the intermediate oxidation state from -3 to +3 we can possible. Like if you want to write, you can get when you are calculating in the compounds. Okay. So now what is the minimum and maximum oxidation state of carbon? If I ask minimum and maximum, see how many are there? 4 electrons are there in the valency. So it can lose all those 4, it becomes +4 as maximum. Minimum will be by gaining 4 more electrons, it becomes 8 electrons, like maximum electrons in its valence. So -4. So it can vary from -4 to +4. Okay. So if someone asks you minimum, just fill valence electrons. If they ask maximum, remove that valence electron. That's it. You will get some charge. Okay. Simple way to remember. Okay. Now tell me here, what is the chromium oxidation state? What is the chromium oxidation state here? Those who are watching through online, just tell me your answer in the comment box. Okay. So look at here. 2 chromiums are there, so 2x I can say. 2 potassiums are there, 2 I am writing. Each potassium is alkali metal, na? +1. Okay. And 7 oxygens are there, 7, and each oxygen we know -2. Overall molecule is neutral, so equals to 0. So 2x will be, see 7 2s are 14, -14 plus 2 plus -12. So -12 if I send this side, it becomes +12. So x will be +6. Okay. So now once again, in order to find maximum oxidation state, what to do?
Take out the
Valence electrons. Now what is the maximum oxidation state of chromium? I am asking you. Maximum oxidation state of chromium. For that you need to know first its atomic number. Chromium atomic number is 24 right now. So chromium 24. So simple way to remember, whatever the atomic number you have seen here, that many valence electrons are there in 3D series. Okay. I mean generalized. This is a simple way to remember. See here chromium atomic number is 24. You can write 3d4, 3d5, 4s1. So how many are there? 4 plus 5 plus 1. So here also you can remember 2 plus 4. So like that. It's a simple way to remember. So 6 valence electrons are there. So we can remove all those 6 electrons, become +6. So what is the maximum oxidation state of chromium? +6. Okay. So now calculate here what is the oxidation state of chromium in this compound. Fast. +6. Here also +6. Okay, next. Look at this. Sorry. Okay, we'll solve 1 or 2 questions, then we'll do remaining things. So find oxidation number of potassium in these compounds. See, this is a JEE main question, easy to answer, very simple. Try this. In this case, K2O is there. How much? Potassium atoms are alkali metals. How many alkali metals are there? +1 for each potassium. Okay, how many are there? 2 are there. So x. So x will be -2. They are asking oxidation number of potassium. Okay. So if they are asking oxidation number of potassium, it will be always how much I told you? plus 1. For alkali metals always it will be plus 1. Okay, so in all options it should be plus 1. For potassium, if they ask for potassium, always it should be plus 1. But if I ask for oxygens, tell me here in this case oxygen oxidation states.
1 plus 1
Oxygen,
minus 1
oxygen here in this case
minus 2
minus 2, already we calculated, minus 2. Next here peroxide form minus 1. In this case minus half, that's it. Okay, but for alkali metals always fixed number, that is plus 1. For alkaline earth metals plus 2, that is also fixed. Okay, next for fluorine its combined states minus 1 always, fluorine, because more electronegative. Okay, remember this. Now tell me here in this case for nitrogens, oxidation state of nitrogen in these compounds. Yes, tell me. See, between nitrogen and oxygen, which is more electronegative? Oxygen. So oxygen minus 2, nitrogen should be plus 2. That's it, simple way. So first one is plus 2. Second one, NO2 plus 4. And here,
plus minus half
nitrogen's oxidation state. See, this is minus 2 for one oxygen atom. So here it should be minus 2, means it is plus 1 for one nitrogen atom. So plus 1. Okay, are you getting how I did this? See, 2x plus 1 into minus 2 equals to 0. So 2x will be plus 2. So x will be plus 1. Okay, now next what about here nitrogen in nitrate ion?
plus 5
Plus 5. Okay, even if I ask for nitric acid, HNO3, that is also plus 5. Okay, so you got your oxidation states. Simply arrange them based on their oxidation states. Nitrate ion maximum, after that nitro, like NO2, next nitric oxide, N2. Second option. Okay, fine. Next, remaining things, we have few more. Mm-hmm. Okay, so will you do this question? Wait, I'll give you. Write this. Do for these two questions. H2SO5. Next, CrO5. Find this fast. So oxidation states of sulfur atoms here and chromium atom here. How much?
Plus 8.
Plus huh. But is that possible for sulfur? Which group element is sulfur? Belongs to 16th group. Which group? 16th group. So valence electrons of sulfur are 6 only, like oxygen family. Okay, like NS2 NP4 electronic configuration for these 16th group elements. So maximum electrons are how many? 6 only. But if we remove maximum electrons from its valency, it becomes plus 6. But if you calculate, you are getting plus 8. Is that possible? No, it is not possible. So now its oxidation should calculated from its structure. See, whenever we have like whatever the calculated oxidation state you did for now. So you got calculated oxidation state as plus 8. See, when calculated oxidation state is greater than its maximum oxidation state, there exist peroxy bonds. What there exist? Peroxy bonds. Because simply you have taken oxides like -2 oxidation state. But if I take peroxy oxygens, it will be -1. So negative charge is decreasing means positive charge also decreases. So it means I am writing sulfur here. So again insert one oxygen like this and one more oxygen like this. After doing this, how many hydrogens are there? 2. So you can keep one oxygen, one hydrogen like this. Still how many are there? 2 more oxygens are there. So I am inserting like this. Now try to calculate its oxidation states. See here, this will be -2. If it is -2, sulfur should be +2 with respect to these 2 bonds. Because electronegative atom oxygen will take this bond electrons towards itself. Similarly, downside also, this will be -2, here it will be +2. And with respect to this bond, oxygen will take bonded electrons, so +1 here, -1 with respect to this one, and here also it will be taken by oxygen, so -1 here, +1 this side. This side also oxygen will take this bond, so +1 for hydrogen. Okay, between these 2 oxygen both are same electronegative elements, so no change in their oxidation states with respect to this peroxy linkage. Okay, but with respect to this, oxygen will be -1, sulfur should be +1. Therefore, what is the net charge present on the sulfur? You can just look +2 from above side and again +2 from below side. Okay, and the next +1 from this side and +1 from this side. So totally +4, +5, +6. So +6 is the oxidation state of sulfur in H2SO5. So name of this compound is Carose acid. What is that? Carose acid. Again in the exam they won't give formula. They just say Carose acid, oxidation state of sulfur in Carose acid. Like that they will ask. Okay. If you calculate for this, how much you will get? If you calculate, you +7 you are getting. Is that +7 is possible? No. Maximum it can show +6. But here it is +7. It means there exists a peroxy linkage. Okay. So try to construct the structure in such a way to get oxidation state lower than +6, equal or lower than +6. That's it. Okay. So then you will get one peroxy linkage. Okay. So try to construct its structure and for this one also. Okay, and we will discuss remaining things in the next class. So do these things. Again, remaining questions you can solve from module. Okay, whatever the exercise questions or DPP1, DPP2 questions are there, try those questions. Okay, we will discuss remaining things in next class. Okay, so those who are watching online, those who are watching through online, so if you have any doubts regarding this topic or any topic from redox reaction, you just write in the chat box. We will discuss in the upcoming sessions. Okay, if you like the content, please click on the like button and you can also share with your friends. Thank you.